programs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice all your entrance exam question papers because you have all of them available there along with the detailed PDF solutions for free. Also, you may download our app. The link is available in the description box. So, students, today we'll be solving your JEE Mains 5 April Shift 2. 5 April 2024. Shift 2, that is your evening paper. I'll be solving the mathematical questions in this particular video. So let's start with it. A very best of luck. Here we go. Question number 1. It says that let be a function -1 to 2, two real numbers given by this function where square brackets t represents greatest integer less than or equal to t, and the number, we have to find out the number of points where f is not continuous. All right, so you have this fx is equal to 2x squared x square greatest integer function minus x. Okay, let's rewrite it. This can be written as a 2x squared plus x minus this plus, I can write it like this. Okay, so if you look at these, what are the doubtful points where it can be like it cannot be continuous? So the doubtful points over here are one is -1 from here, and because -1 it will give me a, okay, then a 0, then 1, then √2, √3, and 2. So these are some of the doubtful points. Let's say at x is equal to √2 and √3. This fx function, which was 2x squared x minus x plus x squared. This is a continuous function. You know this, and also you know this is a continuous function. When you add both of them, you will get a discontinuous function. So first is these 2 points, they are discontinuous. Now let's check for the rest ones. And now let's check for the rest ones. Fx, now this can be written as 2x squared plus x plus, you can write it like this, plus x squared plus x minus the greatest integer function of x. This is nothing but 2x squared plus greatest integer 4x squared plus the fractional part of x. This can be written as a fractional part of x. Now let's go for my f of -1 minus, like I'm going on the negative side. So this can be written like this. Okay, f of -1 minus. So this will be equal to, this will give me a 2 because it's a square over there, plus 1 because this is going to give me 1, and okay, this will give me a 0. So this is equal to 3. Now f of -1 plus this will give me again a 2. And see, this is -1 plus. So now the greatest integer, it will give me a 0 over here and a 0 over here. This is equal to 2. So this is not equal. The LHL and the RHL, they are not equal. So the function is discontinuous at this point. Next, f of 0 minus f of 0 plus. For this, it will be 0 plus 0 plus 1. And for this, it will be 0 plus 0 plus the fraction part, like it will be 0. So this is again not equal, the LHL and RHL. So again, there's a discontinuity at this point. Now let's go for f of 1 minus f of 1 plus. So f of 1 minus this was this function. So this will give me 2 plus 0 plus 1. 2 plus 0 plus 1. And for 1 plus, this will be 2 plus 1 plus 0 again. So this is a continuous function at this. So this is LHL. This is your right hand limit. They are equal. So the function is continuous at this point. Now let's move to the last point where we have to check the continuity was 2 minus and 2 plus. This is LHL and RHL. So 2 minus, this will give me 8. And this is the greatest integer function. So this will give me a 3 and 1. So this is 8, 3, and 1, which is 12. And for 2 plus, it will be 8, 4, and 0. Okay. So this is also equal to 12. That means this is LHL, RHL. They both are equal. So the function is continuous. So these are the 2 points where it is continuous. 1, 2, and these 2. So the function is discontinuous at 4 points, and those are 0, root 3, root 2, root 3, and minus 1. These are the 4 points where the function is discontinuous. Okay. Here we have C option as the right answer. Hope you got that. Let's move to the next question then. Question number 2, the differential equation of the family of circles passing through the origin and having the center on the line y is equal to x is given by what? So this is your origin. Let's say this is the point O, this is your origin, and this is your line y is equal to x. Now you want to derive the family equation of family of circles, which is passing, which is having the center on the origin, sorry, which is having the center on this line. The center may be over here, or the center may be over here. The center may be anywhere, but it should be on this line, and the circle should pass through the origin. These are the 2 conditions for it. So any point, first thing, any point which is lying on this particular line is given by it's having the same x and y coordinates. So the center of the circle will always be given by any coordinates which are having x and y similar. Let that be t. Now the radius, let's solve the radius. Let's say this is point A and this is point B and this is O. So in triangle OAB, applying the Pythagoras theorem, OA square is equal to OB square plus AB square. And OA is what? It is your radius. So radius square is equal to OB is T, of course, because this is the point T comma T. So OB and AB both are T. So that gives you radius square is equal to 2T square. Here's your radius, right? Now the general equation of the circle, when the center and the radius are given to you, this is radius square. So when the general equation of the circle, when the center and the radius are given to you, is given by x minus t square y minus t square is equal to 2t square. Open it up, x squared t squared minus 2x into t, y squared t square minus 2y into t is equal to 2t square. This will cancel, x square y square is equal to 2t x plus y. Let's differentiate both sides with respect to x. This will give me this. This is differentiating both sides with respect to x. So let's make the t subject of formula. Here you will, first of all, I'll divide both the sides by 2. You will have x plus y into y dash is equal to t 1 plus y dash, or t will be given by x plus y into y dash 1 upon 1 plus y dash. So let's fill in this t in, okay, I got this equation. Okay, let's fill this t in equation 1. Fill in equation 1, you will have x square plus y square is equal to 2 into this into this. Okay, so multiplying both sides by this 1 plus y dash is equal to 2 into 1 plus y dash x plus y into y dash. This will give me x square, y square, x square, y dash, y square, y dash. This will give me, let's stick to outside only for the time being. And this will be, wait, it was x plus y. Okay, by mistake, I wrote this is y this. It was x plus y this. So this will give me x square plus xy y dash plus xy this thing. Okay. Or you will have your x square minus 2x square minus y square, and here will be minus 2xy is equal to 2xy y dash plus 2y square y dash minus x square y dash minus y square y dash. This will give me minus this minus y square minus 2xy. Right. Okay. It was plus. Sorry. Okay. So this is equal to, this is xy, and here will be x square minus x square y, and plus y square y dash plus 2xy y dash. So let's say this is minus x square y square minus 2xy. This is equal to, it was x square y dash. Okay, x square and y square, this into y dash. So let's multiply both the sides by minus. So you will have x square y square 2xy is equal to x square minus y square minus 2xy into dy by dx, right? And this will be given by x square minus y square plus 2xy into dx is equal to x square minus y square minus 2xy into dy. So this is the answer to the question. Let's check with the options now. You have here, I think this is the one. Yes, this is the answer to the question. We have option C. Hope you got that. Let's move to the next question. Question number 3, let S1 be the set that contains Z, where Z belongs to complex numbers such that the modulus of Z is less than equal to 5. S2 and S3, they are given by these equations. We have to find out the region bounded by the intersection of S1, S2, and S3. So the very first one, you have S1 as a set Z, where set of elements that contain Z, where Z belongs to complex number such that the modulus of this is less than equal to 5. So let's say your Z is equal to x plus iota y. What will be the magnitude or the modulus of it? It will be given by root of x squared plus y squared. So that means this is less than equal to 5, or you have x squared plus y squared is less than equal to 5 square. If I change the inequality into equality, you will have this. So this means this is the equation of the circle which is passing through the origin and having radius 5. Which means what is S1? This is the area of the circle which is passing through the origin, which is having the center, not passing through, sorry. It is having center at the origin. This, and the radius is equal to 5. Correct. So this complete is your S1. Let's move on to S3 now. Okay, I'll talk about S2, but we'll do that later. First of all, let's talk about the S3, Z1. So here this contains Z, where Z belongs to the complex numbers such that the real part of Z is greater than equal to 0. So what is your Z? X plus iota pi. The real part of it is greater than equal to 0. What is the real part? X. X is greater than equal to 0. Now the same circle, the same complex number, only the positive value of x will be taken. So this is the one. So this was your S1, this is your S2. Combining both of them, the common point is, the common area is this point, this shaded portion. Now let's go to your, this is S3, sorry. Now let's go to your S2. What is your S2? It contains Z, where Z belongs to complex numbers such that imaginary of Z plus 1, I'm opening Z, this is x plus iota y plus 1 minus root 3 iota divided by 1 minus root 3 iota multiply by this is greater than equal to 0. Let's rationalize the denominator, and after opening this, you will have imaginary of x plus iota y plus this minus this plus this minus 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 this whole thing divided by, this is I have to ask like the complex number. So the square will be a plus b into a minus b. Here will be given by a squared plus b squared. So this is 1 plus 3. According to question, this is greater than equal to 0. So imaginary part, you will have x plus 4. This, where it is, this was 1. So x plus 4 minus this, and plus y minus 3 plus 3 iota, and this upon 4 is greater than 0. So we are interested only in the imaginary part. This is the real part and this is the imaginary part. So I'll be taking only the imaginary part. This will, first of all, this and this will cancel. Where this was plus 3. Okay. So you will be left with y plus root 3 iota was written outside upon 4 is greater than equal to 0. 4 will get cancelled out. Okay. Here was your x. I have to write x over here. This was the one. Okay. So you have y plus root 3x is greater than equal to 0. Now this is what? This is a line. This was your circle already, which was having the center at the origin. Then this is the line. Y is equal to minus root 3x. Here the slope is equal to, I'm changing the inequality into equality. Slope for this line is equal to minus this, or this is equal to minus tangent of 60 degree. Right. So that means this angle is taken in the clockwise direction. Minus 60 degree, right? Over here like this. So this is your angle, over here in this clockwise direction, right? This is your minus of tangent 60 degree, and this angle will be this. So this is 60 degree over here, right? And what was this angle now? This is 90 degree over here, and this one will be a 30 degree then. Okay. Now, what we have to take? We have to take according, this is your S2. And what was according to S3? We had to take the positive value of X. And this is, sorry, this is wrong. The positive value of X is in this area. Here the X is positive. Here actually the Y was positive. So this is your S3 where X is positive in this area. That means what I have to take? I have to take this much area for S2. I'm repeating the whole thing now. According to S1, I'm taking the whole circle. According to S2, I'm taking the only positive value of X. And according to, S3, I'm taking the only positive value of X. And according to S2, I'll be taking this much of portion. This this will also be included. So intersection of S1, S2 and S3. What the area now will be? See, this was the area which is bounded by S2. This one, this whole thing was the area which is bounded by S2. If I combine all of them, what I will get is this area. This was your line y is equal to root 3x. And this much area you need for that. Now, what was this angle equal to? This was your line. Okay. So this was 90 degree and we calculated this is equal to 60 degree. So what is the angle made by this? Angle, total angle, for which we need to find out the area. For area is equal to 150. Right now, area of shaded portion is 150 upon 360 into total area, which is pi r square. So this is 150 upon 360 pi r square. Initially, we calculated that was equal to 5. 5, okay, the radius was equal to 5. Here, the radius was equal to 5. So the radius square will be equal to 5 square. This gives me 5 will go 12. So 125 pi upon 12. This is the answer to the question, 125 pi upon 12. And this D option is the right answer. Hope you got that. Let's move to the next question. Question number 4, the area enclosed by the curves y is equal to x into mod of x and y is equal to x minus mod of x is equal to. We are having two equations. First is this and the second is given by this. So if I take this one, so that means y is equal to, it can have two values. It will be plus x squared when x is greater than equal to 0, or minus x squared when it is negative number. Similarly, in this case, the y will be equal to, see, when x is positive, it will give me a 0 and it will give me 2x for lesser values. Okay. And yeah, that will be this. Yes. So that's it. Let's make the graph to understand, because we have to find out the area enclosed by these two curves. So that thing, first of all, this is the, it will give me a 0 over here and this. So this is equal to y is equal to 2x. This line is equal to y is equal to 2x. And another one, you have to y is equal to x square or minus x square. So this will give me like this. For x square, it goes like this when y is equal to x square. And for minus x square, it will go something like this. Right? I have to find out this shaded portion. First of all, let's find out their point of intersection. So the first point of intersection for both of them is the origin, of course, and the second one, and you have y is equal to minus x squared and y is equal to 2x. That means minus x squared is equal to 2x, or x squared plus 2x is equal to 0. This gives me this. So one is either x can be 0, which we already have seen. And the second one is when x is equal to minus 2. When x is equal to minus 2, y will be equal to minus 4. So this is your second point, minus 2, comma, minus 4. Therefore, point of intersection for both are 0, comma 0 and minus 2, comma 4 or minus 4. Yes. Okay. So now the area of the shaded portion, it will be given by, it will go from minus 2 to 0, minus of x square minus 2x dx. Or this will be equal to minus x cube upon 3 minus 2x square upon 2 minus 2 to 0. Or this will be equal to, like, it will be a 0 minus 0 thing minus I'm taking for this minus, it will be plus, and minus 2 cube upon 3 plus 2 into minus 2 square. Okay, this will cancel. So this will be equal to minus 8 upon 3 plus 4. Or this will be 4 upon 3. Square units. So the answer to the question is the D option. 4 by 3. Hope you got that. Let's move to the next question. Question number 5, 60 words can be made using all the letters from this word, with or without meaning. If these words are written as in dictionary, then the 50th word is, okay, you have this BHBJO. So when I'm writing in the dictionary, right? So first of all, which you're having good different alphabets as B, H, and J and O. So the next one, first of all, you are having B, then you are having the words which are starting with H, then you have words and starting with the J, and then lastly, you are having the words which are starting with O. So the ones, with or without meaning, let me repeat, can be the letters. When these are written, the 50th. Okay, fine. So how many are left positions? 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. This. So these are the 4 positions. They can be filled up in 4 factorial ways. Correct? So that means how many words will come over here? 24. Same. 4 factorial ways. 24. Okay. Now you are having here the B will be repeated. So that means that will be 4 factorial divided by 2 factorial, which will give me 12. Okay. Now J, again B and B, it will be repeated. So 4 factorial upon 2 factorial, which is equal to 12 correct? So, okay, now the next one. Over here, O, then you can have a B, B. I'm writing the dictionary. B, B, then you can have H, then J, then O. See, this is 24. Now, if I'm saying commutative frequency, if I'm taking, so this will be 36 and this will be 48. So that means the next one will be 49th. Okay, over here. So 49th will be OBBJ and what will be the 50th? It will be this. You will have a B, B, now J, H. So this will be your 50th one. Hope you got that. And you have option, it was OBB, JH. Option C is the right answer to the question. Hope you got that. Let's move to the next question. Question number 6, let A be this vector, B be this vector, and C be 3 vectors such that this is true. And here is a change. Here is if. So this is not in dot product with it. This line finishes over here. Next is if A dot C vector is equal to minus 29, then you have to find out the value for this expression. Okay. So let's write down. You have C plus I cross A plus B plus I is equal to A, C plus I, this vector. So this C plus I, let's take common. C plus I multiply A plus B plus I cap. And I'm taking A on this side. So this will be A vector. Now this is given by C vector plus I vector is equal to some, this is equal to 0. Okay. So let's take it as some lambda into A plus B plus I. Let's take it as 2 lambda over here. Right? And what is 2A plus B? So let's take these two vectors. 2A plus B vector will be given by 4I 10J minus 2K and plus 2I 2J and 2K. Right? Let's do this I also, add this I also over here. And this will give me 7I and 8J and K will cancel. 7I and 8J, let's fill in this equation. So you have a C plus I is equal to this. Right? Or you have 7 lambda I, 8J. Let's take this I on this side. So you will have 7 lambda minus 1 I plus 8J. Also, you are given that the dot product of A and C vector is equal to minus 29. So what is your A vector? 2I, 5J minus K. I got the C vector. 7 lambda minus 1 I, 8J. This is equal to minus 29. Okay. So this will give me 14 lambda minus 2 plus 40. Yeah, K is missing. So this is equal to minus 29 or 14 lambda is equal to minus 29 minus 38, which is equal to minus 60. Wait. It was 8 lambda G. So this is lambda over here. And this is into lambda. So this will be 40 lambda. Okay. So this line will be 14 lambda plus 40 lambda is equal to minus 27. Or you have a 54 lambda is equal to this. Or lambda will be equal to minus 1 by 2. So what does your C vector now become? C vector was your 7 lambda minus 1 I plus 8 lambda J. So if I fill the lambda value in this equation, you will have minus 7 by 2 minus 1 lambda minus 4 J. or this will be minus 9 by 2 I minus this. Right. Now what you had to find out was this C vector dot this vector. To find was C vector dot minus 2I j and k. C vector came out to be minus 9 by 2I minus 4j dot product minus 2I j and k. This will be equal to this will give me 9 and minus 4. So this is 5. The answer to the question, option B. Hope you got that. Let's move to the next question then. Question number 7, consider three vectors A, B, C. Let the magnitude of A is 2, magnitude of B is 3, and A is equal to the cross product of B and C vector. Where alpha, if alpha lies between 0 to pi by 3, that is 0 to 60 degree, this is the angle between B and C vectors. Then the minimum value for this expression is equal to. So you are given so many things. First is you have the A is equal to the cross product of B and C. Magnitude of A is equal to 2. B is 3. Also know one thing from here, you have that the dot product of A and B, this is equal to 0, and A and C is also equal to 0. Now let's pick up this. You have to find out the magnitude of C vector minus A vector square. This is given by C square, vector magnitude square, A vectors magnitude square, minus 2 CA, and this is what something I don't know. A's magnitude was 2, 2 square 4 minus 0. So this is equal to 4 plus magnitude of C square. Let's find out the magnitude of C now. For that, let's pick up this equation. You have A is equal to B cross C. So this will be given by the magnitude of B, magnitude of C, and sine of angle between them, which is this is alpha, right? And the magnitude of A, this is equal to 2 in the question. Magnitude of B is 3 in the question, and this is equal to this. So 2 by 3 sine alpha is equal to C, right? And C vector's magnitude, right? Yes, so what will be the square of it? Because I'm interested in the square, so this will be given by 4 upon 9 sine square alpha. So C square minus A square vector, which was equal to this thing, this is equal to 4 plus 4 upon this, right? Now, because 27 is a constant, over here you need to have to find out this value. 27 is a constant, and in order to have the minimum value, of this vectors, a magnitude of C minus A, you have where alpha was lying between 0 to pi by 3. So you need to have the maximum value for sine alpha, because sine alpha is lying in the denominator. We need max value of sine alpha, and see alpha is lying between 0 and pi by 3. So the maximum value will be sine pi by 3, which is equal to sine 60 is root 3 by 2. So this is the maximum value it can have. Now 27 C minus A square, it was equal to 4. This 27 multiplied 4 plus 4 upon 9 sine square alpha. This will be equal to 27 into 4 outside. 1 plus 1 sine square alpha. This will give me this. Okay, and this will be 8 and 108. This will be 3 plus 4 upon 3. This will cancel. 36. So 7 into 36. This will give me, here I forgot to write down this 9. So this is equal to 36 multiply. Wait, this will be 4 by this. I'll redo the sum from here. So this is equal to 108, 27 plus 4 upon 27. So this will be equal to 108 multiply 31 upon 27. And this will give me 27 fours are, right? Yes, this is it. This is equal to 124. So this is the answer to the question 124. C option is the correct answer. Hope you're clear with this. Let's move to the next question. Question number 8, let A be this point and B be this point with the 2 points and P be the variable point above the line AB such that the area made by the triangle PAB is 10. If the locus of P is given by this equation, you have to find out what is 5A plus 2B equal to. So let's have 2 points here. This is A and B. Let's say this is any point P such that the area of the triangle PAB is 10. This and this is the one. Okay. So first thing, let's say locus of P is given to you at AX, BY is equal to AX plus BY is equal to 15. Now let's take the point P to be some having coordinates H and K. Area of triangle PAB, it will be given by, because if I'm taking the coordinates as H and K. So the general equation for the coordinates, for the area when the coordinates are given to you, this is given by x1, y2 minus y3, x2, y3 minus y1, x3 into this. The magnitude should be modulus. It should be 10 according to the question because the area is given to you 10 in the question. Okay. Or here I'm taking the general one. So I'll write down area. Now, according to the question, if I'm filling in the coordinates, this will be half magnitude minus 1, 3 minus k, 2, k minus 1, h 1 minus 3 modulus, this is equal to 10, or this will be minus 3 plus k plus 2 k minus 1 plus h minus 3h, this is equal to 20. Okay, so this will be 3k minus 2h, here is the modulus, and minus 5. This is equal to 20. Or now it can have either 3k minus 2h minus 5 is equal to 20 or minus 3k minus 2h minus 5 is equal to 20. From here you have minus 2h plus 3k is equal to 25. From here A will be minus 2, B will be 3. And here you will have 2h minus 3k is equal to 15. From here, A will be 2 and B will be equal to minus 3. So you need to find out 5A plus 2B. So what here will be 5A plus 2B. This will be 5 minus 2 to this minus this will be 4. Or here it will be 5 into 2 plus 2 into minus 3, which is equal to 4. So these are the two possible answers, 4 and minus 4. And I have 4 in the options. So that makes the option to be the correct answer. Hope you got that. Let's move to the next question then. Question number 9, let alpha, beta, gamma be the image of this point on this line. You have to find out the sum of alpha plus beta plus gamma. So, all right, here is your point P with the coordinates 8, 5, 7, and this is the image of this point. This is the point Q. Right, this is the line, let's say L1. So L1 here is given by x1 minus 1 upon 2, y plus 1 upon 3, z minus 2 upon 5. Let's say this is equal to some gamma. So any point on this line will be given by, let's say x, y, z. This is equal to 2 lambda plus 1, 3 lambda plus 1, and 5 lambda plus 2. This is Q and this is V dash. This is your alpha, beta, and gamma. Now, direction ratios of PQ will be given by, this will be 8, right? So this is 2 lambda minus 7, 2 lambda plus 1 minus 8. This will give me 2 lambda minus 7. Similarly, this will be 3 lambda minus 6 and 5 lambda minus 5. Now, direction ratios of line this are 2, 3, 5. Are 2, 3, 5, right? Therefore, 2 into 2 lambda minus 7, 3 into 3 lambda minus 6, 5 into 5 lambda minus 5. This is equal to 0. On solving this, this is 9 lambda minus 18, 25 lambda minus 25. And this is 13 and 13 and 38 lambda minus 32. So minus this 57. This is equal to 57. So lambda is equal to 57 upon 38, which is 3 by 2. Therefore, the Q point will be given by, from here, 2 lambda plus 1, 3 lambda plus 1, and 5 lambda plus 2. So 2 lambda, this is 2 lambda plus 1. So this will give me 2 into 3 by 2 plus 1. Then 3 into 3 by 2 plus 1. Then 5 into 3 by 2 plus 2. Or this will be equal to 4. This will be equal to 7 by 2. Actually, there is minus 1 over here because here was plus 1 and here should have been a minus 1. Okay. So, okay, this is 7 by 2 and this will give me 15. This will be 17 by 2. All right. 19 by 2. Yes. So these are the coordinates of your Q. Now, see, Q is midpoint on PP dash. Correct? So that means alpha, beta, gamma. That's all. This will be given by 4. We have to solve this. So 4 will be equal to, that was your 8 plus alpha upon 2. And 7 by 2 is equal to 5 plus beta upon 2. And 19 by 2 is equal to 7 plus gamma by 2. Okay, let's solve them. So you will have, first of all, let's solve gamma. This 2 and 2 will cancel. And you will have this as 12. Gamma is equal to 12. And let's solve for alpha. This is alpha will be equal to 0 because 8 and 8 will get cancelled. From here, this 2 and 2 will cancel. Beta will be equal to 2. So we got here alpha as 0, beta as 2, and gamma as 12. You have to find out the sum of alpha, beta, and gamma, that is equal to 40. So this is the answer to the question, option C. Hope you got that. Let's move to the next question then. Question number 10. If the constant term in the expansion of this expression, where x is not equal to 0, is given by this, you have to find out the value of 25 alpha. Let's write down the expression. You have fifth root of 3 divided by x plus 2x divided by third root of 5 whole raised to power 12. So any general term tr plus 1 is given by, here it will be 12cr first term, this upon x, 12 minus r, 12x upon this in raised to power r. Now, what is the coefficient of x over here? This is, I'm ignoring everything. I'm just talking about the coefficient of x. This will be given by x raised to power x. I'm taking in the numerator. So this will be minus 12 plus r, and this one will give me x raised to power r. So this is x raised to power minus 12 plus 2r. For the constant term, x power should be 0, right? So that means minus 12 plus 2r is equal to 0, or r will be equal to 6. So that means constant term will have the coefficient, constant term. This will be 12 C6 multiply. This is okay. This is your first term. Fifth root of 3. Fifth root of 3. So this is this. Okay. And give me a minute. Here was 12 minus 6. So this will be 12 minus 6, which is equal to 6 only. And here one was 1 upon 5 raised to power 1 by 3 power 6, like this. So this is 12 C6 3 power 6 by 5 into 5 power minus 6 by 3, correct? And there was 2 also, so 2 power I have left, 2 power 6. Okay, now let's expand. So you have here, this is 12C6, this is 12 into 11, 10, 9, 8, 7 upon 6, 5, 4, 3, 2, 1. So this can be written as 3 raised to power 6 upon 5 can be written as 3 into this. And this cuts, this will be 1 upon 25 multiply 2 power 6. So let's do the cancellations that can be made. Here is 5 fours are 20. So it will cut like this, and this will cut at this 3. Or better to cut this one. Anyways, let it be this one only. So here you have this will be 11 into 3 into 7 into 2 can be written as 2 power 2. And this is 3 into 3 power 1 by 5 into 2 power 6, whole thing divided by 25. Let's do the calculations now. This will give me 693 upon 25 into 3 power 1 by 5 into 2, like this is 2 power 2 and this is 2 power 6, this is 2 power 8. And here will be this upon 20. Yes, everything is done. So this is the answer to the question. 693 upon 25 into 2 power 8 into fifth power of 3. Now let's check with the options. Okay, this is equal to this, alpha into this. So this is equivalent to alpha into 2 power 8 into fifth power of 3. So that means alpha is equal to 693. Yeah, upon 25. So 25 alpha is equal to 693 upon 25 into 25, which will give me 693 only. So this is the answer to the question, 693. Option C is the right answer. Hope you got that. Let's move to the next question then. Question number 11, let f and g be the functions from real to real numbers be defined by fx is equal to this and gx is equal to this function. So you have to find out the f of g of x. Okay. You have fx is equal to mod of x minus 1. So what will be f of g of x? See, this will be having two conditions, when x is greater than equal to 0 and when less than equal to 0. So in this case, it will be mod of e raised to power x minus 1. And in this case, it will be x plus 1 minus 1, right? So this will be like this. This will be mod of e power x minus 1. And here will be mod of x. This is when x is greater than equal to 0. And this is when x is less than equal to 0. Right. So here this is f of g of x. This can be written as e raised to power x -1 when x is positive, and this will be equal to -x when x is negative, of course. Right? How will it look like on the graph? This is your coordinate axis. Okay, this is your graph. Okay. And -x, this line will go something like this. This is -x. And e raised to power -x, e raised to power x -1, this line is this. E raised to power x -1 is this line. So you can easily see this is neither 1, 1 nor on 2. Right? So which is the right answer to the question? Option A is the right answer to the question. Hope you got that. Let's move to the next question. Question number 12, let the circle C1 given by this equation and C2 be the circle. We're having it centered -1 and 0. Radius 2, if the line of the common chord of C1 and C2 intersect the y-axis at the point P, then the square of the distance of P from the center of C1 is. We're having two circles. This is C1 given by x square, y square minus 2x minus 2y plus 1 is equal to 0. So C2, you're given the center and the radius. Let's frame the equation for C2. You're given the center, so it will be x minus of -1, which is x plus 1, y minus 0, which is y square, is equal to radius square. This will give me x square plus 2x plus y square plus 1 minus 4 is equal to 0, or x square, y square plus 2x minus 3 is equal to 0. These are the equation of the two circles. Now, for the common chord, the equation will be given by C1 minus C2 is equal to 0. So this will be x square, this x, y, like the 2 will get cancelled, and you'll be left with minus 2x, minus 2x minus 2x minus 2y, and there is no y over here, and plus 1 plus 3. This is equal to 0, minus 4x minus 2y plus 4 is equal to 0, or you have 2x plus y is equal to 2. Correct? Okay, so intersect the y-axis. Now, given if the line of the chord of common like C1, C2, they intersect the y-axis at the point P. So at y-axis, you know, x is equal to 0. So what will be the point? 0 plus y is equal to 2. So y is equal to 2. Therefore, what will be the coordinates of P? It will be 0, 2. Now, what do you have to find out in the question? Square of the distance of P from the center of C1. So let's find out the center of C1 as well. The C1 was given by x square, y square minus 2x minus 2y plus 1 is equal to 0. C is minus half the coefficient of x minus half the coefficient of y, which is 1 and 1. And let's find out the distance of these two between these 2 points. So let's say this is C. So you have to find out CP. This is given by 0 minus 1 square, 2 minus 1 square, which is equal to root of 2. Now you have to find out the square of it. So square of it is equal to 0, 2, sorry. That is, first option is the right answer. Hope you got that. Let's move to the next question. Question number 13, let the set S contains these elements be partitioned in 3 sets A, B, C with equal number of elements such that A union B union C is equal to S. That means, according to the question, we're having 3 sets and the combined of them A union B union C is equal to S, and you are given that A intersection B is equal to B intersection C is equal to A intersection C is equal to null. So that means A, B, C, they are distinct entities. They don't, they are not same. They are having nothing in common, and the union of all of them is equal to S. Right. So now next, what you are given that S is equal to 2 and 4, which can be written as 2 power 2. Next is 8, 2 power 3. Next is 16, 2 power 4. And last is 512, which is equal to 2 power 9. So that means S contains 9 elements. In the question, you are given that A, B, C have equal distribution of elements and they have nothing in common. So that's for sure. A will have 3, B will have 3, and C will have 3 elements each. So possible or maximum number of possible partitions in A, B, and C. See, A, like any one of them can have 9, like out of 9, they have to pick up any combination of 3, and then will be left 6. From there 3, and then after that picking up 3 from there, you'll be left with 3. So 3C, 3. This will be given by 9 factorial upon 3 factorial into 6 factorial. 6, 3, 3, and this is 1. So this is 9, 8, 7 upon 3 into 2. Multiply 6, 5, 4, 3 into 2. Multiply 1. So this cancels 3 and 4. So this is 84 to 20. This gives me 1680. This is the answer to the question, option A. Hope you got that. Let's move to the next question then. Question number 14, the values of m and n for which this system of equations has infinitely many solutions satisfies which of these equations? For the infinitely many solutions, you know the determinant. If I write these equations in the matrix form, first of all, this will be given by 1, 1, 1, 2, 5, 5, 1, 2m. And for the infinitely many solutions, you know determinant of this will be equal to 0. Okay. So let's find out the determinant. This will be given by 1 into 5 into m minus 10 minus 1 to m minus 5, 4 minus 5. This is equal to 0. This gives me 5m minus 10 minus 2m plus 5 minus 1 is equal to 0. Or you have a 3m is equal to 6, or m becomes 2. Okay, now let's solve n. For that, you know also that D3 is also equal to 0. D3 will be given by 1, 1, 4, 2, 5, and 17. And this is also equal to 0. 1 into 5n minus 34 minus 1 into 2n minus 17 plus 4 into this is equal to 0. Or you have 5n minus 34 minus 2n 17 minus 4 is equal to 0. This gives me 3n minus 38 plus 17 is equal to 0, which gives me n is equal to 7. I got the two values. M is equal to 2 and n is equal to 7. Now, let's solve this. Let's check which equation it satisfies. So this becomes 4, first one, plus 9 squared, that is 49, minus 2 minus this. This gives me minus 9, which is equal to 44, not 46. No. Next, n square plus 11. Now this gives me 53 plus 11, which is 64. That's right. Sorry, this is supposed to be 9. And plus n, that's supposed to be 9. So this gives me 62. And that's not right. That's incorrect. Next is m squared, which is 4. And 49 plus m into n, which is 14. This is not 68 again. You have this 4 and 49 minus 14. This gives me 53 minus 14, which is 39. So this is the right answer to the question, option D. Hope you got that. Let's move to the next question then. Question number 15. The coefficients of A, B, C in the quadratic equation, this are from this set. 1, 2, 3, 4, 5, 6. If the probability of the equation having one real root bigger than the other is P, we have to find out the value of 216P. So Here is your equation, ax plus bx plus c is equal to 0. For the roots to be real and distinct, because they are showing that one root is bigger than the other, that's very much obvious. So that means the roots in this equation are real and distinct. So this is possible when b square minus 4ac is greater than 0. So let's check which are the cases. See, when b is less than 2, no value of a and c will be possible. So that means I will have to take the values bigger than that. Let's take when b is equal to 0. B is equal to 3. So in that case, 4ac will be less than 9, or AC will be less than 9 by 4. So let's consider these cases when A and C will have, like they ordered where they can have. So it can have like 1 and 1, right? Then it can have this or this. So these are the three cases when B is equal to 3. Next one, B is equal to 4. So in this case, what your AC will be? AC will be less than 4. So the ordered pair AC can have will be 1, 1, 1, 2, 2, 1, and this. How many cases are there? 5. When B is equal to 5. AC is less than 25 by 4. So the ordered pairs in this case, 1, 1, 1, 2, 1, 3, 2, 2, 4, 1, 1, 4, 2, 2, this, then it can have 3, 2, 2, 3, 5, 1, 1, 5, 1, 6, and 6, 1. You will calculate, this will be 14 cases. Now the last one, when B equals 6. So your AC in this case will be less than B square, that is 36 by 4, that is equal to 9, right? AC will be less than 9. So the possibilities for AC will be 1, 1, this, 3, 1, 1, 3, 2, 2, 4, 1, 1, 4, 3, 2, 2, 3, 5, 1, 1, 5, 1, 6, and then it can have a 2, 4. And how many cases will be there total? You will have a 16 cases. So what are the total cases now? It will be given by 3, 5, 14, and 16, a total of 38 cases. So the required probability, this is number of favorable cases upon the total number of cases. Total number of cases are how much? Sorry guys, accidentally I erased whole of the sum. Anyways, you can rewind the video and watch it again. We were there, like we got the probability that was equal to number of favorable cases upon the total number of cases. So the favorable cases, they came out to be, it was 38. And what were the favorable cases? There are 6 possibilities, like 1, 2, 3, 4, 5, 6. So, and how many digits, alpha variables were there? There were 3. So this is 6 raised to power 3. This is equal to 38 upon 216. And what you have to find out is this was equal to your P. So 216P will give me 38 upon this into 216. So the answer to this question will be 38. Option B is the right answer to the question. Hope you got that. Let's move to the next question. Question number 16, let A, B, C, D and A, E, F, G be the square of side 4 and 2 units respectively. The point E on the line segment AB and the point F is on the diagonal AC. Then the radius R of the circle passing through the point F and touching the line segments BC and CD satisfies which of these equations? All right. So here is your triangle square ABCD. First thing, AC is diagonal of ABCD. Therefore, AC will be given by root of 4 square plus 4 square, which is equal to 4 root 2. Similarly, AF is diagonal on AEFG. So AF will be given by root of this, which is equal to 2 root 2. Now, what is your give me a minute. What is your CF equal to? CF is equal to AC minus AF. That makes 4 root 2 minus 2 root 2, which is equal to 2 root 2. Now, see, one thing, this is the diameter of the circle, right? This R plus R. What I want to know it, I don't want this side, this particular side, I don't want that. But let's say this is O, A dash, C and B dash. Let's consider square O, A dash, C, B dash. You will have OC as this root of R square plus R square. That will be equal to root 2 into R, right? And so that means what is your CF becomes now? CF will be equal to FO plus this is OC, right? CF is FO plus OC and this was R. OC we just calculated, it is R root 2. So this is this value. CF we calculated over here, that was 2 root 2. So this is the one. Let's write it. 2 root 2 is equal to R into 1 plus root 2, right? Or this is R plus root 2 into R, or 2 root 2 minus root 2 into R is equal to this. You will have, let's take root 2 common. This will be 2 minus R is equal to this, or root 2 will be equal to R upon 2 minus R. Now let's square both the sides. You will have 2R square, 4 plus R square minus 4R, and this will be 8 plus 2R square minus 8R is equal to R square, or you have R square minus 8R plus 8 is equal to 0. So this is the answer to the question, option B. Hope you got that. Let's move to the next question. Question number 17, let beta mn be represented by this integral, where m and n are positive integers. If integral of this is equal to alpha into beta with the coordinates b, c, then what is the value for 100 a plus b plus c? So here you have, let's write down, I'll start with this integral. Let's say this integral I is equal to limit 0 to 1, 1 minus x raised to power 10 raised to power 20 into dx. So I'll put x raised to power 10 is equal to t. This will give me 9 into, not 9, it will give me 10 into x raised to power 9 dx is equal to dt, or dx will be equal to this. Okay, now you have x raised to power 10 is equal to t. This gives me x is equal to t raised to power 1 by 10. Or x raised to power 9 will be given by t raised to power 9 by 10. Or x raised to power minus 9, this will be given by t raised to power minus 9 by 10. So this dx will be equal to t raised to power minus 9 by 10 into 1 by 10 into dt. Right, now let's get back to our integral. Your integral now will be equal to 1 by 10. I'm taking outside limit 0 to 1. It will be 1 minus t whole raised to power 20, t raised to power minus 9 by 10 into dt. So further, this will be 1 by 10, 0 to 1. Now I can write it like this. T can be written as 1 by 10 minus 1, and 1 minus t can be written like this. 1. 21 minus 1 dt. So if you look at this This resembles this equation. X raised to power m minus 1 into 1 minus x raised to power n minus 1. So this is equivalent to, a minute, that was integral 0 to 1 x raised to power m minus 1 into 1 minus x raised to power n minus 1 dx. So that was your equal to beta m n. So comparing both of them, you get this is equivalent to 1 by 10 beta. So here m is equal to 1 by 10 and n is 21. I got the values for m and n. Now, this is equivalent to this if I compare it. So that was alpha into beta. What was b comma c? Right. From here you have alpha is, wait, that was a, not alpha. So that was your equivalent to a into beta b comma c. So that means your a is 1 by 10 and b is 1 by 10 again, and c is equal to 21. You had to find out 100 a plus b plus c. So 100 a plus b plus c. This one solving will give you 2120. This is the answer to the question 2120, option D. Hope you got that. Let's move to the next question. Question number 18. Let alpha into beta is not equal to 0 and A is given by this, B is given by this matrix. If B is equal to this, is the matrix of cofactors of elements of A. What is the determinant of A, B product? So here you have A matrix. Let's find out the cofactors of it. Cofactors of A will be given by, see, for this will be like C11, C12, C13, 21, 22, 23, 31, 32, 33. Fine. For A11, I'll be taking this, like leaving this and this. This will give me 2 alpha squared minus alpha beta. Now, this is second row. This is first row, second column. So minus 1 raised to power 1 plus 2. This will give me minus 1 over here. Now I'll be leaving this and this. So it will be 2 alpha square plus beta square. So this is this. And further, now here will be plus. Now I'll be taking this 3, leaving this and this. This will be alpha square minus plus. Alpha square plus alpha beta. So alpha square plus alpha beta. Following the same method, this is your second row, first column. So leaving your second row and first column, this will be 2 alpha square minus 3 alpha. So minus, because this is second row, first column, minus 1 raised to power 1 plus 2. It will give me minus 1 only. Here you will have 2 alpha square minus 3 alpha. This will have 2 alpha beta plus 3 beta. And this is minus 2 alpha beta. This will give you alpha beta minus 3 alpha minus beta square minus 3 alpha. And alpha beta minus alpha square. These are your cofactors of the A matrix. Now you are given that this is equal to this B matrix. So that means they two are equal. If these two are equal, so comparing each element, you will have 2 alpha square minus alpha beta is equal to 3 alpha. Or this is involving squares. I'll leave it. Okay, the next one, you will have this one, that's minus 2 alpha square minus beta square is equal to minus 9. Okay, the next one will be alpha square plus alpha beta is equal to 3 alpha. Fine. Okay, next. So there are so many comparisons. If I pick up this one, alpha beta minus 3 alpha, this one is equal to 2, because I compare this with this. Let's pick it up. alpha into beta minus 3 alpha is equal to minus 2 alpha. Or you have alpha into beta is equal to alpha. That gives you alpha minus alpha beta is equal to 0, or you will have this. So that means either alpha is equal to 0 or you have beta is equal to 1. Now you are given that alpha into beta cannot be equal to 0. So that means alpha is not equal to 0. For sure you are having beta is equal to 1. I got one value. Beta is equal to 1. Now let's compare this. Minus beta square plus 3 alpha is equal to 5. So this is minus 1. This, or you have alpha is equal to 2, you will get. So I got the value for alpha and beta. Now what does your A matrix becomes? Let's fill in to get your A matrix. I'm using the value alpha is equal to 2, beta is equal to 1. The A matrix will be 1, 2, 3, 2, 2, 1, minus 1, 2, and 4. So determinant A into B, this is equal to determinant of A multiply determinant of B. So this is equal to determinant of A, determinant of adjoint of A transpose. Now, why is that? See, B is equal to it is the cofactors of A matrix. And what do you mean by the, like, whenever I had the adjoint of any matrix, this is a transpose. Like, if I say B is equal to adjoint of A, so any matrix, like, if I do the transpose of this matrix, I will get the adjoint of matrix A. So these are the cofactors. If I take the transpose of this matrix, I will get the adjoint of A. And then B is equal to, the determinant of B is equal to adjoint of A transpose determinant. And let's find out the determinant of A. A determinant of A will be given by, I'm finding the determinant of A. This is 1 into 8 minus 2 into 8 plus 1 plus 3. Okay, plus 3, 4, plus 2. This will be 6 and minus 18. 6 and 18. So this will be equal to 6. Right. And what is a transpose? Adjoint of A transpose. This is given by, what is the part? This is a 3 by 3 matrix. Right. This is determinant of A part 3 minus 1. So this is 6. Into determinant of A, this is this, which is equal to 216. So this is the answer to the question. 216. We have the option as the correct answer. Hope you got that. Let's move to the next question. Question number 19. If y of theta is given by this equation, then at theta is equal to pi by 2, what is the second derivative of y plus first derivative of y plus y equal to? You have y theta is equal to 2 cos theta plus cos 2 theta divided by this plus 4 cos 2 theta, 5 cos theta plus 2. So let's do one thing. Let's open up this numerator. You will have 2 cos square theta plus 2 cos theta minus 1. So, you know, cos 2 theta is equal to this. So now the new denominator. This opening up cos 3 theta, this will be 4 cos cube theta minus 3 cos theta, and this will be 2 cos square theta minus 1, 5 cos theta plus 2. This will be 2 cos square theta plus 2 cos theta minus 1. Whole thing divided by, this is 4 cos cube theta plus 8 sine, no, sorry, this is cos square theta plus 2 cos theta minus 2. Okay, now let's keep the numerator as such, cos square theta, cos theta minus 1. Open it up, the denominator, because I want to make the factors. So this is 4 cos cube theta, and let's say this is 4 cos square theta, 4 cos square theta plus 4 cos theta minus 2 cos theta minus 2. or this is 2 cos square theta 2 cos theta minus 1 whole thing divided by, let's take 2 cos theta common from here. You have 2 cos square theta and 2 cos theta, and I'll take this minus 1. I'm taking this one. Okay. And now we have utilized this one, and that one. So you're left, let's plus 2 over here. So this will be 2 cos square theta, 2 cos theta minus 1. This will give me 2 cos square theta, 2 cos theta minus 1 divided by 2 cos theta minus, no, this will be plus 2 and 2 cos square theta, 2 cos theta minus 1. What will happen? Cancellations from the numerator and denominator, and you will have 1 upon 2 outside, 1 plus cos theta. This is equal to 1 upon 4 cos square theta by 2, or this is equal to secant square theta by 2 upon 4. That was equal to your y theta. So y dash theta, this will be equal to 1 by 2, 1 by 4. This is outside. This will be C2 secant theta by 2 into secant theta by 2 tangent theta by 2, because the derivative of secant theta is secant theta into tangent theta into the coefficient of theta, which is 1 by 2. So this makes it, this 2 and this 2 will cancel, and you will have 1 by 4 secant squared theta by 2 tangent theta by 2. This is the first derivative of y. Let's go on to find out the second derivative of y. This is 1 by 4, right? First function derivative of second. So first function into derivative of second, it will give me secant square into theta by 2 derivative of tangent, that is also secant square theta by 2 into derivative of coefficient of theta by 2, theta, that is equal to 1 by 2 plus 1 by 4 second function into derivative of first. So secant square theta, this is the first function. This will give me 2 secant theta by 2 into secant theta's derivative is secant into tangent. Okay. And this whole thing will be multiplied by 1 by 2, which is the coefficient of theta. So this 2 and 2 will cancel, and ultimately you will have your 1 by 4. This will be 1 by 4, here will be 1 by 4 secant power 4 theta by 2 plus 1 by 4. This is equal to secant square theta by 2 into tangent square theta by 2, right? This is your second derivative of the function. Now what you have to find out? You have to find out at theta is equal to pi by 2. You have to find out this value. First of all, y dash of pi by 2. This will give me 1 by 4, 1 by 2, secant power 4, pi by 4, right? Plus 1 by 4, secant square pi by 4, tangent square pi by 4. Cos pi by 4, that is equal to 1 by root 2. So its inversion will give me, this is 2. You have cos pi by 4 is equal to 1 by root 2. So its square will give you 1 by 2. And secant is inverse of cos. So this will give me this. 1 by 4, this is 2, and tangent of pi by 4, this is equal to 1. This is equal to 1 by 4 plus, here it was power 4, it was power 4, so it will be 2 square. So this will be 2 by 4. Okay, so 2 by 4 plus 2 by 4, this will be 1. That means I got y dash for pi by 2 is equal to 1. Now y dash, see this is double dash, sorry, second derivative of y for pi by 2. Now the second derivative for first derivative, that is y dash theta, it was this function. Let's write down y dash theta is equal to 1 by 4 secant squared theta by 2 tangent theta by 2. So y dash of pi by 2 is equal to 1 by 2 secant squared pi by 4 tangent pi by 4. This will give me 1 by 2 into 1. Or that's equal to 1 by 2. Okay. What was your y theta? Y theta was this value. Okay, that's a number of value. So I'm filling this is theta is equal to pi by 2. I'm directly filling for pi by 2. This is cos pi by 2 cos pi divided by cos 3 pi by 2 cos pi cos pi by 2 and 2. This is 0 minus 1 divided by 0 4 into minus 1 plus 0 plus 2. This is minus 1 upon minus 2, or that's equal to 1 by 2. Now you have to find out the values for y dash pi by 2, y double dash pi by 2, y dash pi by 2, y pi by 2. This came out to be 1. This was 1 by 2. This was 1 by 2. This answer is true. So this is the answer to the question. We have D option as the correct answer. Hope you got that. Let's move to the next question. Question number 20. For x greater than equal to 0, the least value of k for which this expression 4 raised to power 1 plus x plus 1 raised 4 raised to power 1 minus x k by 2 and this, they are the three consecutive terms of the AP is equal to. So you have to find out the value of k. You are given that this is the first term. Then you have k by 2. And then you have 16 power x, 16 power minus x. They are in AP. So if they are in AP, that means 2 into k by 2 is equal to this sum. Correct? So that means you have k is equal to, I can write it as 4 multiply 4 power x plus 4 multiply 4 power minus x plus 16 can be written as 4 power 2x and minus 2x. Correct? Let's put 4 raised to power x is equal to t. So you have k is equal to 4t plus 4 upon t. Thus I can write plus t square plus 1 upon t square. Or this is t square plus 1 upon t square plus 4 and this t plus 1 upon t. This is equal to t plus 1 upon t whole square plus 4 into t plus 1 upon t minus 2. Now let's say that was equal to your k. Let's put t plus 1 upon t as some y, where y belongs to 2 to infinity. Okay. So k becomes equal to y squared plus 4y minus 2. That makes y to be given by, like, applying the quadratic formula, minus b plus minus b squared minus 4ac upon 2a. So y will be here. This is a is 1, b is 2, 4. A is 1, b is 4, and c is minus 2. So this will be minus 4 plus minus b square minus 4 a into c. Or I think it will be better if we see it like this. You are given in the question that x is a positive number. If x is a positive number, t will always be greater than equal to 1. Because like if you are having x is equal to 0 also, then t will be 1. T will always be a number greater than equal to 1. And if t is a number greater than equal to 1, then this will be, if I'm taking the least value of t. So if this is 1, then this will be 1 plus 1. That means the least value of y will be 2. So that's it. I don't think we need to solve it to like any finding out the y through the quadratic formula or anything. There's no need of it. We can have the directly, like we can say that k will have the minimum value when y is equal to 2. K will be minimum, then y will be equal to 2. So that means k minimum will be equal to 2 square, 4 into 2 minus 2, or this will be 10. The value of k will be equal to 10. That's option A. Hope you understood that. Let's move to the next question then. Question number 21, let the mean and the standard deviation of the probability distribution given by this be mu and sigma. Respectively, if the difference between the two is 2, we have to find out the sum of 2. So the very first thing, the summation of the probability is equal to 1. That means 1 by 3 plus k plus 1 by 6 plus 1 by 4 is equal to 1. This makes k as 1 minus 1 by 3, 1 by 6, and 1 by 4. Let's take the LCM. You have 12 as LCM. So 12 minus 4 minus 2 minus 3. This gives me 3 upon 12, or k's value comes out to be 1 by 4. Right. Now this next, the mean is equal to summation xi p xi. Right. So that means this is equal to mu is equal to 1 by 3 alpha plus k plus 0 minus 3 by 4. K's value was 1 by 4. So this is alpha by 3 plus 1 by 4 minus 3 by 4, or this is equal to alpha by 3 minus 1 by 2. This is mu. Now the sigma, the standard deviation, is equal to summation of xi square pxi minus mu square. So this is equal to, let's fill in the values. You have this as root of 1 by 3 into alpha square k plus 0 plus 9 by 4 minus mu was the alpha by 3 minus 1 by 2 whole square. This gives me alpha squared upon 3 plus 1 by 4 plus 9 by 4 minus alpha squared by 9 plus, no, this will be minus 1 by 4, and yeah, this will be minus 2 alpha upon 3. 2 will cancel. So this will be the one. This will give me alpha. Let's take the LCM. This will be 3 alpha squared minus alpha squared, and minus alpha upon 3. And this will cancel, plus 9 by 4. This is equal to 2 alpha squared by 9 minus alpha upon 3 plus 9 by 4. Right? So now, okay, you are also given in the question that sigma minus mu is equal to 2. That gives me sigma is equal to mu plus 2, squaring both sides. You will have, this will be equal to 2 alpha squared upon 9 minus alpha upon 3 plus 9 by 4. This is equal to, what is your mu? That was initially we solved, it was this. Alpha upon 3 minus 1 by 2 plus 2 whole square. This gives me 2 alpha square upon 9 minus alpha upon 3 plus 9 by 4 is equal to alpha upon 3 plus 3 by 2 whole square. This is equal to alpha square by 9 plus 9 by 4 plus alpha. Okay, now this 9 by 4 will cancel from both sides. So you will have your 2 alpha squared upon 9 minus alpha squared upon 9 minus alpha upon 3 minus alpha is equal to 0, or you will have alpha squared upon 9 minus 4 alpha upon 3 is equal to 0. Alpha squared minus 12 alpha is equal to 0. If there is a small change, it was supposed to be minus 2 alpha upon 3 into 1 by 2. So this minus minus, there was minus outside, this was plus, and this was plus, this was plus, 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 and this will be minus 2 alpha upon 3, which will give it 6 over here. Okay. So let's take alpha common. Alpha minus 6 is equal to 0. This gives me the value of alpha as 0 and 6. These are the two possible values of alpha. So I got the value for alpha. That's 0 or 6. And let's take the value. We just solved the value for k is equal to 1 by 4. What I have to find out is sigma plus mu. So let's find out the sigma value. The sigma was equal to this 2 alpha square upon 9 plus alpha by 3 plus 9 by 4 under the root 2 alpha squared plus 9 alpha by 3 plus 9 by 4. And the value for mu was equal to this. Where was mu? Alpha by 3 minus 1 by 2. Right? So for the value of alpha is equal to 0, let's say for value of alpha is equal to 6 and the k is definitely 1 by 4 in both the cases. Let's solve for sigma. This will be equal to 0, 0 and 9 by 4, which gives you 3 by 2. Or here this will be equal to summation, this under the root of 4, this will be 2 into 6 upon 9 plus 6 upon 3 plus 9 by 4, which on solving will give you 7 by 2. And for mu, mu was equal to pi by 3 minus 1 by 2. So 0 minus 1 by 2, this is equal to minus 1 by 2. And here will be equal to pi by 3, which is 6 upon 3 minus 1 by 2. So this is gonna give me 2 minus 1 by 2, which is equal to 3 by 2. Right. So in this case, you have the sum of 2 as 1 and the sum of 2 will be equal to 7 by 2 plus 3 by 2, which is equal to 5. So these are the two possible answers. Either it can be 1 or 5. But according to the NTA, you have 5 as a right answer. So that means this is the right answer to the question. Hope you got that. Let's move to the next question. Question number 22. Number 22, let y is equal to yx be the solution for this differential equation where y of 0 is equal to 0. Then the area enclosed by this curve and the line y minus x is equal to 4 is. First, let's pick up this differential equation. You have dy by dx plus 2x upon 1 plus x square whole square into y is equal to 1 x raised to power e raised to power x raised to power x into e raised to power 1 upon 1 plus x square. So now if you see it clearly, this is your integrating factor can be calculated from here. So integrating factor of this linear differential equation is e raised to power 2x 1 plus x square whole square dx. This is equal to e raised to power minus 1 upon 1 plus x square. Right, because this is what this is the numerator is having the derivative of the denominator. So this is given by this. This is your integrating factor. Or now the equation will be y into your integrating factor, which is e raised to power minus 1 upon 1 plus x squared is equal to integral of x into integrating factor, which is this. X into, okay, first of all, this into integrating factor, let's write it here. Dx. So if you solve it, you will have y into e raised to power this. And they will actually cancel out each other. This will be equal to x square by 2 plus. See, you are given in the question that y of 0 is equal to 0. So that means 0 is equal to x square, that is 0 plus c, which gives you c is equal to 0. So what does your this equation now becomes? It becomes y into 1 upon 1 plus x square is equal to x square upon 2. Or you have y is equal to e raised to power, here was minus, and yes. So this is 1 plus x square into x square upon 2. This is the value of your y. Now you have to find out the area between this y and the line y minus x is equal to 4. Let's find the area between both of them. So this is your fx is equal to this, and therefore, wait, this is y into this. So there's a small correction. Here is supposed to be -1. There's a correction in the question. So this is equal to y into e raised to power this is equal to x square by 2. And so you have to find out the area between x square by 2 and the line y minus x is equal to 4. This will look something like this. This is your curve y is equal to x square by 2, and your line y is equal to x plus 4, right? This is your line, and this line will be going like this somewhat. Y is equal to x plus 4. Let's find out the point of intersection of this two. So for that, you have x square by 2 is equal to x plus 4, or x square is equal to 2x plus 8, or you have x square minus 2x minus 8 is equal to 0, or this will be given by x square minus 4 plus 2 minus 8, or this, right? You have two values of x as -2 and 4, and the corresponding values for y will be, okay, I don't need actually, this is, let's keep it this much only. So it will be, this is -2, so it will come over here, and here is your 4. We can calculate, let's calculate y also. So y is equal to 8 in this case, and in this case y will be equal to 2. Right. So now you have to find out the area between them. So this is the area that you need to find out. Required area will be given by limits -2 to 4. It will be x plus 4 minus x squared by 2 dx. -2 to 4 minus x cubed by 2 minus 2x square dx, or this will be minus x power 4 upon 4 into 2 minus 2x power 3 upon 3 limits this. So, sorry, I'm so sorry. This was minus. I shouldn't have. Wait. Here was the minus sign between them. I don't know why I multiplied them. So this is x plus 4 minus x square by 2 dx. This will be x square by 2 4x minus x3 x power 3 by 6 limits this. So upper limit minus lower limit, this will give me 16 by 2 plus 16 minus 64 by 6, and now you will have a minus of -2 square, which is 4 upon 2 minus 8, and it will give me 8, right? Yes, it will be plus 8 upon 6. This will give me 8 plus 16, which is 24. And this is 32 and 3. So minus 32 upon 3 minus this will be 2 minus this, minus 6 plus 4 upon 3, or this will give me 24 plus 6 minus 32 by 3 minus 4 upon 3, which is equal to 30 minus this will be 36 upon 3, or this will give me 12. So 32 minus 12, this is going to give me 18. This is the answer to the question, 18. All right. 18 is the right answer to the question. Hope you got that. Let's move to the next question. Question number 23, the number of solutions of sine square x plus this minus this is equal to 0, where x lies between -pi to pi is given by. Let's write down, you have sine square x plus 2x minus x square sine x minus 3 into x minus 1 whole square is equal to 0. I can write it like this, sine square x plus 3 minus this sin x minus 3x minus 1 whole square is equal to 0, right? So this will be sin square x plus 3 sin x minus 1 square sin x minus 3x minus 1 whole square is equal to 0. Let's take sin x common from here. You will have a sin x plus 3 minus x minus 1 whole square. Again, you have sin x plus 3 over here. So the two factors will be sin x plus 3 and sin x minus x minus 1 whole square is equal to 0, right? So that means either this is equal to 0 or this equal to 0 or both are equal to 0. One thing is for sure that if I put sin x plus 3 is equal to 0, that gives me sin x is equal to minus 3, which is not possible at all. Sin x cannot never have the value minus 3. So that means this is equal to 0. Sin x minus 1 whole square is equal to 0, right? So that means, let's check the, you have to find out is number of solutions. Okay, so that means, let's plot the graph over here. First thing, you have sin x is equal to x minus 1 whole square. So let's plot the graph now. This is the graph for sin x, because it is going from minus pi. Let's say this is minus pi, and let's say over here you are having pi, and over here this is 1 lies between. So first of all, you are having the curve x minus 1 whole square. This is a parabola which is passing through this point. This is the vertex for the parabola. This is the one. And next, the sine curve, this is given like this. It is passing through the origin, right, over here. So how many points of intersection are there? There are 2 points of intersection. This is number 1 and this is number 2. So that means how many solutions are there? There are 2 solutions. Hope you got that. Let's move to the next question. Question number 24. Let the point minus 1 alpha beta lie on the line of the shortest distance between these two lines. And the value of alpha minus beta whole square is equal to. So let's say this is the line L1 and L2. And let's say this is the point A and B on this line. And this is the shortest distance between these two lines, these 2 points. So see, whenever I'm talking about the shortest distance, that means I'm talking about the perpendicular distance between the 2 points or the 2 lines. That's it. So let's say this is your line L1 and let's say this is equal to some M and this is your line L2. Let's say this is equal to some N. So any point on A on the line L1 will be given by minus 3M minus 2, 4M plus 2, 2M plus 5. And here it will be given by minus N minus 2, 2N minus 6 and 1. Right. So what will be a B vector given by? It will be given by minus 3M minus 2 plus N plus 2. And 4M plus 2 minus 2N plus 6, 2M plus 5 minus 1. Right. So this will be equal to minus 3M plus N, 4M minus 2N and plus 8, 2M plus 4. Now you have that AB is perpendicular to L1 and L2, both, right? If they are perpendicular, that means the dot product is equal to 0. So what is your L1? The direction ratios were minus 3, 4, and 2, and AB is given by these direction ratios. So that means minus 3M plus N, 4, 4M minus 2N plus 8, 2M plus 4. This is equal to 0. Okay, so this will give me 9M minus 3N, 16M minus 8N, 32, 4M plus 8 is equal to 0. So this is like combining these three. I have 29M minus 11N plus 40 is equal to 0. Okay. Now AB is perpendicular to L2 also. According to this, minus 1 into minus 3 plus this 2, 4m plus this and the plus a 0 of 2m plus 4 is equal to 0. Because the dot product of AB and L2 will be equal to 0. So this makes 3m minus n, 8m minus 4n, 16. This is equal to 0, right? This will give me 11m, 5n plus 16 is equal to 0. Let's solve both of them simultaneously. Multiply this with 5 and this with 11. So this will give me 145m minus 55n plus 200 is equal to 0. And this will be 121 minus 55 and 176. Okay, minus plus minus. So 24m, they will cancel, plus 24 is equal to 0, which will give me m is equal to minus 1. So 11 into minus 1 minus 5n, 16 is equal to 0, minus 11 plus 16 minus 5n is equal to 0. This gives me n is equal to 1. M is equal to minus 1, n is equal to 1. Let's frame the points A and B. On solving, A was equal to like minus 3m plus whatever the thing, what was it? See over here. So this was your A and B. Putting in the values of m and n, you will get A as 1, minus 2, 3, and B will come out to be minus 3, minus 4, and 1. Now, AB line, this will be given by x minus 1 upon 1 minus of minus 3, this will be 4. Okay, and this is y plus 2 upon 2, z minus 3 upon 2. Right, and this will give me x minus 1 upon 2, y plus 2 upon 1, z minus 3 upon 1. So what you had in the question was this point lies on this line, like say this is the point, minus 1, alpha and beta. Okay, so that gives you alpha is equal to minus 2, beta is equal to 3. You have to find out alpha minus beta whole square, right? So this will be minus 2 minus 3 whole square minus 5 whole square, that is 25. So this is the answer to the question, 25. Hope you got that. Let's move to the next question. Question number 25, if 1 plus root 3 minus root 2 upon this, plus this, plus this, plus this, till infinity is equal to 2 plus, here is plus, all these things. So where A and B are integers and the greatest common divisor between A and B is equal to 1, you have to find out the value of this expression. So first thing you're given, let's say this is equal to S. S is equal to, let's put root 3 minus root 2 is equal to some x. So this will be given by x upon 2 root 3. And this is root 3 minus root 2 square. You will solve it. You will have a 3 plus 2 minus 2 root 6. Similar, same, right? So this can be written as x square upon 18. Similarly, this will be x cube. You can solve and check. This is equal to x cube upon 36 root 3 and so on till infinity, right? Again, let's do one thing. Put x upon root 3 is equal to t. Here, x is equal to root 3 minus root 2. So you will have, let's go to this s now. This is equal to 1 plus t upon 2, t square upon, this is equal to 6, right? A cube by 12 by 20, so on till infinity. So let's segregate them. I can write it as 1 plus t into 1 minus 1 by 2, right? Plus this will be t square 1 by 2 minus 1 by 3 t t cube 1 by 3 minus 1 by 4, t4 1 by 4 minus 1 by 5, so on till infinity. So s will be equal to 1 plus t plus t square by 2, t cube, t4, so on, minus t by 2, t cube, t square by 3, t cube by 4, t this by 5, and so on till infinity. Right? Hope you're clear till this. So now s will be equal to, I'll do one thing. I'll take this, for the time being, I'm keeping this one aside. So t plus t square by 2, t cube by 3, t power 4 by 4, right? And I will introduce, let's take 1 by t outside and this. I'm just explaining. So I have introduced a minus 1 over here. For that, I'll be adding a 1. And this one is also added over here. This one is here. And I'm taking a minus 1 over here, which I'm adjusting over here. Hope you got like what I have done. So this will be equal to plus t square upon 2 plus t cube upon 3, t power 4 upon 4, and so on. See why I have done this? Because I want like power and the denominator to be same. Got it? Okay. So now this is equal to, s is equal to same thing. So let's write 2 over here. 2 plus, this is 1 minus 1 by t. I have taken common, and this is equal to minus log of 1 minus t. See, this is 1. So 1 into 1 by t common, because these two are same. I have taken them common. And that is equal, this is equal to minus log of 1 minus t. Okay. Now, s is equal to 2 plus, this can be written as, I'm adjusting this minus 1 by t minus 1 log of this, correct? So this is now, I think I should put the value of t. What was t? T was equal to x upon root 3. And what was your x? That was equal to this. Right. So 2 plus, this will be root 3 minus root 2 minus 1 log of 1 minus root 3 minus root 2. This will be 2 plus root 3 plus this log of this. Correct. So they will cancel, and you will have, wait, this was, I did a small mistake. Here was t now. So this was this. Okay. And this thing I will redo. This is root 3 minus root 3 plus this upon root 3. Okay. Now they will cancel. Let's write it once again clearly. This will be equal to 2 plus root 2 upon root 3 minus root 2 log of this root 2 upon root 3. Correct. So this is 2 plus, let's rationalize the denominator. So this will be root 2, root 3 plus root 2 upon 3 minus 2 log of 2 by 3 for 1 by 2. Okay. So 2 plus, this is root 6 plus 2 upon 1 into 1 by 2 log 3 by 2. This is natural log only. So this is 2 plus root 6 by 2 by 2 plus 2 by 2 log E 3 by 2. This is 2 plus, this will be root 3 by 2, right? Yes. So this can be written like this and plus 1 log E 3 by 2. If I compare it with the given equation, what was that? This one, I told you there is a plus over here. So if I compare it with the given equation, which is 2 plus root of B upon A plus 1 log A upon B. Okay. So here you have A is equal to 3 and B is equal to, wait. Yes, A is equal to 2 and B is equal to 3. A is equal to 2, B is equal to 3. Here is supposed to be 2 by 3. I have just shifted it. This was 2 by 3. Okay. So, yes. So, A come out to be B, A come out to be 2 and B is equal to 3. You have to find 11A, 18B. So, this plus this will give me 76. So, you have 76 is the right answer to the question. Hope you got that. Let's move to the next question. Question number 26, let 8 be greater than 0 be a root for this equation. And if limit this is equal to alpha plus beta into root 17, where alpha and beta belong to integers, what is alpha plus beta equal to? You are having this equation 2x squared plus x minus 2 is equal to 0. So let's say this is having two roots, a and b. And if I see this equation, which is 2x squared minus x minus 2, if I take the minus common from here, is equal to 0, then it will have the roots as 1 upon a and 1 upon b. So let's consider first 2x squared plus x minus 2 is equal to 0. So here x can have, like it is having two roots. First root can be given by applying the quadratic formula. This will be minus 1 plus minus b squared minus 4ac upon 2a. So this will be given by, the roots will be given by, let's say this is x. So the two roots will be given by root 17 minus 1 upon 4 and b will be given by minus root 17 minus 1 upon 4. Now the second equation, which was, let it be like this only, minus 2x squared plus x plus 2 is equal to 0. It will have two roots. So 1 by a, this is the first root, which is equal to this, and 1 by b is, I'm taking minus common, root 17 plus 1. Okay, so this equation can be written as minus 2 into x minus 1 upon a, x minus 1 upon b, or this is minus 2 into x minus 1 upon a, x minus minus plus this. Okay, so now let's consider the limit which is given to you, x approaching 1 by a, 16, 1 minus cos 2 plus x minus 2x square, whole thing divided by 1 minus a x square. Okay, so this becomes limit x approaching 1 by a. You know 1 minus cos a is equal to 2 sine square a by 2. So I'm taking this 16 outside. This can be written as 2 sine square 2 plus x minus 2x square upon 2, whole thing divided by, let's take a square common. This will be 1 minus a minus x whole square. So this becomes 32 limit x approaching a. Now let's break it up. You know, this is equal to 1 by 2 and this was having these two factors. So using 1 over here, you will have this as minus 2 into x minus 1 upon a, x plus this whole square. And the denominator, let's take the minus a square also outside. And this will be, I can write it as 1 minus a, 1 upon a minus x whole square. This can be written as x minus 1 upon a whole square, right? So this was sign. So see, I'm having this variable like x minus 1 upon e square. This is present in the numerator and the denominator. And let's introduce this one. So this x plus 4 upon root 17 plus 1 whole square. Let's multiply here also. X plus 4 upon root 17 plus 1 whole square. So this becomes equal to 32 upon a square. And this thing will give me a 1. And you will be left with x approaching a, this. Okay. This is equal to 32 upon a square. This will be 1 upon a, and this is minus 1 upon b whole square. So 32 upon this, a was equal to 4 upon root 17 minus 1, and b was equal to 4 upon root 17 plus 1 whole square. So 32 a squared 4 root 17 plus 4 root 17 minus 4 upon a square minus b square whole square. Okay. 32 upon a square. Let it be a square only for the time being. So this is 8 root 17 upon 16 whole square. This will cancel. So you will have 32 a square. A square was, what was a square? This is 4 square into root 17 minus 1 whole square. And this is 17 upon 4. Okay, this will cancel at 2. And you will have a, and this will cancel. So you will have 17 outside, 17 by 2 outside, 17 plus 1 minus this. So this is 17 upon 2, 18 minus this, or you have 17, 9 minus root 17. I got my mistake. This was a square, and this is actually 1 upon a square. So this should have been 4 upon root 17 minus 1 whole square. And I wrote this thing, right? This was inverse. So let's redo this sum from this part. So now this is 32 upon a square. A square is root 17 minus 1 square into 4 square. And this is 17 by 4. So this 4 and this 4 will cancel. And you have a 32 into 8 into 32 into 4 into 17. And the denominator is going to have 17 plus 1 minus 2 root 17. Okay, so this is 32 into 17 into 4 upon 18 minus this, or this will be like taking 2 common from the denominator and cancelling the numerator. You will have 32 into 7 into 2 upon 9 minus this. Let's rationalize this way. Correct. So you will have 32 into 17 into 2, 9 plus root 17, a square minus b square, which is equal to 32, 17 to 9 plus root 17 divided by 64. So this will cancel out. Okay. You will have 79 plus root of 17. So this is equal to 17 nines, which is 153 plus 17 root 17. If I compare it with the given equation, which is the alpha plus beta root 17, that means you have alpha 153, beta is equal to 17. So your alpha plus beta is 170. So this is the answer to the question 170. Hope you got that. Let's move to the next question then. Question number 27. If f of t is given by this integral where t lies between 0 to pi, then the value of this integral is equal to what? Okay. Let's start with writing the integral ft is equal to limit 0 to pi 2x dx 1 minus cos square t sine square x. Let's apply the King's rule, which says that integral f limits a to b fx is given by sum a plus b minus x. So now this integral ft will be given by limits 0 to pi. This will be 2 pi minus x divided by, this will be, what was that? 1 minus cos square t into sine square pi minus x dx. Or this ft will be given by 2 pi 0 to pi 1 minus cos square t into sine square pi minus x. See, sine pi minus x is equal to sine x only, because pi will not change the trigonometric ratio, and pi minus x, it comes in the second quadrant where the sign is positive. So this will also be a positive only. Sine x, it will be sine square x only. Okay, minus 2x 1 minus cos square t sine square x dx 0 to pi. Okay, so this is nothing. See, this is your ft only. So this becomes your ft. This makes it twice of ft is equal to twice pi. I'm taking this outside, dx upon 1 minus cos square t into sine square x. This limits 2 and 2 will cancel. See, now this is an even function, right? So if this is an even function, you can write down ft as 2 pi again. Let be, now the limits will change. It will be from 0 to pi by 2. 1 minus cos square t into sine square x. Okay. Now let's do one thing. Divide the numerator and the denominator by cos square x. Or you can say secant, multiplying the numerator and the denominator by secant square x. This will be 2 pi 0 to pi by 2 secant square x. Secant square x minus cos square t. This would be tangent square x and a dx over here. Okay. This is your ft. Right. Let's put tangent of x is equal to some z, which gives me secant square x dx is equal to dz. So now this ft will be equal to 2 pi. Limits will also change. Now it will be 0 to infinity, because when tan 0 is 0 and tan pi by 2, this is infinity. So this will be dz upon 1 plus sine square t into z square. Okay. This will give me, let's take it outside, sine square t. This is dz upon 1 upon sine square t plus z square. So this is limits were 0 to infinity. So this is this under sine square t into okay. This will be 2 pi upon sine square t multiplied by 1 upon this, because you know the integral of 1 upon x. This is equal to 1 upon a into tangent inverse x upon a. So this is the one, and here will be tangent inverse z into sine t, right? The limits will this. Now let's put z is equal to tangent of z. This will be sine square t into sine t. This is tangent x into sine of t. See, I'm putting the z value, so the limits will be now 0 to pi by 2. Okay, so this is 2 pi upon sine t. tangent inverse, this will be infinity minus 0. And tangent inverse infinity exists for pi by 2. This gives me pi square upon sine t. This is your f of t. Now in the question, what you had to find out was this integral. Limit 0 to pi by 2, pi square upon ft. To find limit 0 to pi by 2, pi square upon ft and dt. So this is this pi square upon pi square into sine t, which is this, or you will have what's the integral of this sine sine this is equal to cos minus cos 0 to pi by 2. This will give me minus cos pi by 2 minus of minus, this will give me a plus cos 0, which is equal to 1. So this is the answer to the question 1. Hope you got that. Let's move to the next question. Question number 28, let the minimum and the maximum values for this expression where x belongs to real numbers be small and capital M respectively. Then the difference between the squares of both of them is equal to. So let's say first of all, this y is equal to this. Y is equal to root of 8x minus this, or you have y square is equal to 8x minus x square minus 12, or you have 8x square minus 8x plus 12 plus y square is equal to 0. This gives me x minus 4 whole square minus 4 plus y square is equal to 0, or you have x minus 4 whole square plus y square is equal to 2 square. Now this is the equation of a circle where the center is at 4, 0 and radius is 2, right? The center is 4 and 0, radius is 2. This circle represents something like this. This is the point 4, 0 and this is your circle. This is 2, this is 2. Okay, let's say this is the point A and this is the point B. And here is the point P for which is lying over here. Let the maximum and minimum values for this. So let's solve this. First, you have root of 8x minus x square minus this minus 4 whole square plus x minus 7 whole square. So this is y minus 4 whole square and x minus 7 whole square. This again represents a circle with the center at 7, 4, right? And there is no radius. That means it represents a point. So this is a point P, 7, 4. Correct? Now, the maximum distance, the maximum and the minimum value for this. So the maximum and the minimum value, maximum 1 will be given by this PA square. Okay. And let it be a perpendicular distance, PQ be a point which is perpendicular from P to the circle. So PQ is the shortest or the minimum value. So M is equal to the maximum value and small m is equal to the minimum value. Okay. Now you had the coordinates of P, which was 7, 4 and A had the coordinates 2, 0 because the radius is 2. So this point A will be having the coordinates at 2, 0. So this is equal to root of 7 minus 2 square 4 minus 0 square, which is equal to 5 square, and this which is equal to PA square. Okay. PA is equal to this. So this is equal to root of 41 and PA square will be equal to 41. Correct. Now the point P was having the coordinate 7, 4 and Q is on the circle x minus 4 square y square minus 2 square is equal to 0. So this distance is given by, say, the M, or you can say PQ square will be given by, this will be root of 7 minus 4 square 4 minus 0 square minus the radius whole square. Okay, this will give me 9, 16 minus 2, which is equal to 9. So PQ square or your small m is equal to 9. That means you got your capital M as 41 and small m as 9. So m square minus m square will be equal to 41 square is this, and this is 81. So 1600 is the answer to the question. Hope you got that. Let's move to the next question. Question number 29. Let a line perpendicular to this line touch this parabola at the point P. The distance of the point P from the center of this circle is what? So what you already can, like, we can easily get the center of the circle. What is the center of the circle over here? This is minus G minus F, that is minus half the coefficient of X minus half the coefficient of Y. So you already got the circle C center. I need to have the point P in order to find the distance between the two. Okay, now it said let a line perpendicular to this line touch this parabola at the point. So line perpendicular to 2x minus y is equal to 10. This will have y is equal to 2x. Wait, y is equal to 2x minus 10. So that means the slope of this line is equal to 2. So what will be the line slope of the line which is perpendicular to this? Slope of the perpendicular line, that will be equal to minus 1 by 2, because you know the product of this product of slope of two perpendicular lines is equal to minus 1. Now I got the slope of that line. Now it is given it touches this parabola. So that means line is tangent to this parabola. Let's say the slope of this parabola at the point where it is touching is M. So let's say point at which that line touches the parabola y square is equal to 4x minus 9 b small m. Okay, so the point where this line is touching this parabola, suppose this is the line, and suppose let it be any parabola. This is y square is equal to this. So this is somewhat, let it be like this parabola, and this line is touching this parabola at this point. So at this point, the slope of the line and the parabola will be same. So that means this m is equal to minus 1 by 2, right? Now, the general equation for the parabola with the slope m is given by m into x minus 1 plus 1 by m. This is the general equation. Now, I already told you the point at which the line is the tangent to the parabola. That means the slope of the line and the slope of the tangent at that point is same. So that means this is equal to minus 1 by 2 x minus 9 plus this. This is equal to y, or y will be equal to minus x plus 9 upon 2 plus 2 upon 1. Or you will have 2y is equal to minus x plus 9 plus 4. Or you have x plus 2y minus 13 is equal to 0. Right. Here is minus, like there was minus over here. So here is supposed to be minus, and this is supposed to be minus 5. Okay. So this is x plus 2y minus 5 is equal to 0. This is the equation of the line, right? We got the equation of the line. Now let's get back to the question. What do we have to find out? They are intersecting at the point P. So solving the tangent and the parabola, because at the point, this point P is common to the point P is common to the parabola and the line as well, both of them. Right? What was the equation of the parabola? It was y square is equal to 4x minus 9, and the equation of the line x plus 2y is equal to 5. So let's solve. You will have this is let's say y is equal to 5 minus x upon 2. So this will give me 5 minus x upon 2 whole square is equal to 4 into this, or you will have here 25 plus x square minus 10x is equal to 4 4s are 16, this. or you have x square minus 10x plus 25x minus this minus 144 plus 144 is equal to 0, or you will have x square minus 26x plus 169 is equal to 0. This is x minus 13 whole square, so that means x is equal to 13, and the corresponding value of y you will solve and get minus 4. So this is the point of contact P, that is 13 and minus 4. We already solved the center of the circle. I already told you the center of the circle is at 7 and 4. So center of circle is 7 comma 4. So this P, let's say this is O. So OPO will be given by root of 13 minus 7 square minus 4 minus 4 whole square, or this is equal to 3664. That means you have 10 as the answer. 10 units. Hope you understood that. Let's move to the last question of this paper now. Question number 30. This says the number of real solutions for this equation is, let's write down the equation. You have x multiply x plus 5 plus 2 multiply x plus 7 minus 2 is equal to 0. Here the two breaking points are minus 5 and minus 7. Let's see them on the number line. This is minus 7 and this is number minus 5. Now let's consider three cases. The first case, when x is greater than minus 5. So in that case, it will be x into x plus 5 plus 2 into x plus 7 minus 2 is equal to 0. X squared plus 5x plus 2x, 7x, and this will be 14 minus 2, 12 is equal to 0. So this will give me 4 and 3. This, so you will have the two factors, x plus 4, x plus 3, which gives me two possible values for x, that is minus 3 and minus 4. So there are two solutions. And second case, when x lies between minus 7 and minus 5. Okay, so in that case, it will be x minus 5 plus 2x plus 7 minus 2 is equal to 0, minus x squared minus 5x to x 14 and 2. It gives me minus x squared minus 3x plus 12 is equal to 0. X squared plus 3x minus 12 is equal to 0. So you have x is equal to, applying the quadratic formula, minus 3 plus minus b square minus minus plus 4ac, that is 48 upon 2a. Or this is minus 3 plus minus root of 57 upon 2. Okay, so there are the two possible values. One is minus 3 plus root of 57 upon 2, and another is this upon 2. See, this will give me a positive value and this will give me a negative value between minus 5 and 7. So this is not possible, and this is, of course, you have one solution from here. Okay, now the third one, when x is less than equal to minus 7. So in this case, you will have it as x into minus x minus 5 to minus x minus 7 minus 2 is equal to 0, minus x square minus 5x minus 2x minus 14 minus 2, or you have minus x square minus 7x minus 16 is equal to 0, x square 7x plus 16 is equal to 0. So here x will be given by minus b plus minus b square minus 4ac upon 2. See, discriminant is negative in this case. So that means the roots will be imaginary. So no solution over here. Imaginary roots. So this will have no solutions. How many total solutions are there? 2 from here and 1 from here. So there are total of 3 solutions. Hope you got that. So students, with that, we have completed all the 30 questions of this paper. And don't forget to visit our website www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions. You may also download our app. The link is available in the description box for the better preparation of your exam. So students, keep shining, keep rising high, and don't forget to watch our other videos as well. Best of luck. Bye.